one another?
Complementary angles, right?
Uh, corresponding,
Oh,
corresponding.
right. Okay.
All right. So corresponding are congruent, which means you could set these equal to each other. Could you solve for x for us, please?
Okay. 2.
X is 2. Now, this is like kind of part one of this. The next thing is to put the x value back in to one or the other or both, depending on the problem. Could you do that for us, please?
What do you mean? So just like
Substitute
4,
it back in. Yeah, so instead of x, put in 2. You're multiplying 9 by x, or 4
so like
times x.
18 plus 8 and then 8 plus 18.
Yeah, and are they the same? Because they should be.
Yeah.
So the reason you do that is that's the angle measure. Okay, that's the actual value here. Like it becomes what did you say? 18 plus 8, 26 degrees and 26 degrees. Like that. Okay, now did you guys talk about all the possible corresponding angles in your class? Maybe.
Yeah. So like,
Let me grab a picture here to help give you the right. Okay, so give me some corresponding angles here that you see.
so 2, 6, 1, 5, 4, 8, and 3, 7.
All right, good. And you write them as congruent statements. All right, very good. Now there's a couple of others that you might want to remember here. So we just talked about corresponding. You remember alternate interior and alternate exterior from class?
Yeah. Alternate interior would be like 4 and 5, right? 3
Agreed?
and 6.
Yes. How about alternate exterior? What would that be?
1 and 8 and 2 and 7.
Okay. Now consecutive interior, that's like 3 and 5 and 4 and 6. The
But
first three are congruent. What do you know about consecutive interior? It's not congruent.
I th I think we called it like, wait, trying to
These add to
remember.
180.
Yeah.
Yeah. All right. So let's take a look at another problem here. What is just as important as being able to solve it is to know, which of these five is it? Is this these angles corresponding, alternate interior, alternate exterior, consecutive, interior, exterior.
Alternate exterior.
They are. So are they congruent? Do they add up to something?
Um, yeah, that would be congruent.
They are congruent. So they are congruent. So 2x plus 7 equals 59. Could you solve that for x for us, please?
26.
X equals 26. Good. Okay. So this is kind of the standard way that the angles could be presented, the lines could be presented where they're horizontal, but they don't always have to be. Here is another problem for you to look at. And again, it'd be good if you could tell me what kind of angles these are. This is the parallel, by the way.
Alternate exterior.
Yes. So are they congruent? Do they add up to something?
Yeah, they're congruent.
They're congruent. So 5x minus 35 equals 110. Could you solve that equation for us, please?
15.
You said 15 on
Hmm.
5. All right. I think maybe you didn't solve this correctly. Do you add 35 to both sides? Be bigger than 15.
Oh,
What is the x value?
29.
Yes, x is 29. Good. Now to see if that works, you can put it back in for x and hopefully you get 110 degrees. If you want to. You don't have to. Right. Let's look at some other problems here. Okay, here is another possibility. What kind of angles are these?
Um, I don't remember the one you
Grab list
said it
here.
was because, like, in my class, we said it a different way.
Okay. There's a couple
So,
ways to say, are the like there's two things to think about is like where are they? Are they in the interior or exterior? And the other one is like how do they relate to this transversal? Are they on both sides of it or are they on one side of it?
consecutive interior.
Yeah, so sometimes those are called same side. Maybe that's what you guys are using.
Yeah, we call them
Same
like,
side.
I don't, wait, I kind of forget, but it was something like something angles on the same side of the transversal.
Yeah, I've only ever heard consecutive or same side, but maybe there are other ways of saying it. So these, what is the relationship? Are these congruent or do they add up to something?
They add up to 180.
Yes. So could you now solve that for x and then put that back into the original equation?
X equals 20.
Now you really do want to put this back in to get the two actual angle measures.
Okay. So the bottom one, that's 120, and then the top one's 30. I mean,
Top
sorry,
one is 60.
60.
All right, good job on that. All right, a few more problems for us to work on here. All right, go ahead and tell me what kind of angles these are. I'm gonna grab this list again. I think that could help seeing it over and over again. What kind of angles are these?
Um, Consecutive exterior.
So just be careful where you're, sometimes they're pointing differently than where they're, those are the two angles in red.
Oh, oops. Uh, Corresponding.
Yes. And what do you know about corresponding angles?
They're equal.
They're congruent. Equal is different than congruent in this class. So go ahead and set those equal and solve for x, please.
Wait, sorry, real quick. How would like equal and corresponding be different? Because don't they basically mean the same thing?
You know, congruent is not the same as equal. It's a very small, nuanced thing in the class, but it's only because you're in this class. Congruent means something different than equal. Equal means they have the same like measure. Congruent is like they're physically the same. It doesn't change what you do. It's just that the wording does matter in the course.
Okay.
So you do set them equal, and it is because they are congruent.
I'm having trouble solving this one.
11x minus 5 equals 7x plus 27. So you move the smaller variable to the larger side. So you're going to subtract 7x from both sides. And then you're going to add 5 to both sides. So this gives you 4x equals 32. Do you have X for me?
Oh, 8.
Okay. All right. So now the next step is to put those back in. Can you put 8 back into both of these and see if you get the same number for both?
Okay, so for the one like P, I guess, the one with the line P,
Yeah, sure.
that would be 80, wait, 83.
Okay.
And then Q1, that would be 83.
Are you surprised that they're the same?
No.
Yeah. Good. Okay. That was a little bit tougher. Let's look at another one here. Let me grab a snip of this one. Let me know if you need any break at all. And it's kind of repetitive what we're doing today. Okay. What type of angles are these?
Consecutive interior.
Yes. Same side interior. So are these congruent or do they add up to something?
Add up to 180.
They add up to 180. So 9x plus 3 plus 4x minus 5 equals 180. How are you doing on this one?
Um, X equals 14. That's what I got.
X equals 14. All right, let's take a look. 13x minus 2 equals 180. Add 2 to both sides, so 13x equals 182. It is 14. Very good. Now, can you put that value back in to find the two angle measures?
All right. So the one on line W,
Yep.
that would be 129
Okay.
degrees. The one on line V, see, that's 51.
It is 51. Good. All right. Any questions on that?
Mm-mm.
Okay. Let's see what other problem types I have. Hopefully this isn't too dull or boring for you. Yeah, I got a couple more here. All right, here is another problem for us to look at. All right, so what type of angles are these?
Those are alternate exterior.
Yes. Are they congruent or do they add up to something?
Congruent.
They are congruent, yes. So could you set those equations equal to each other and solve for x? Any questions on how to solve this?
I think I did it wrong the first time, so I'm redoing it.
Okay. All right, sounds good. I'm gonna have us transition to just solving some equations after this one.
Okay. Keep getting six, but I know that isn't correct.
Okay, yeah, let's take a look here. Maybe my handwriting was so poor that that could be the issue. You're gonna subtract 1x from both sides and then add 20 to both sides. So that's 30 equals 3x. So x, when you divide by 3x, ends up being 10.
Okay,
All
well,
right, let's go ahead.
sorry. I added X and 4X because I thought that's what I was supposed to do.
So there, you got to decide if they're on the same side or not. So let's do some problems here. Let's just reset. Um, let's just solve some equations. Now, when there's variables on both sides, all right, when they're on both sides, you move from the smaller to the larger. So you're going to subtract 3x from both sides.
Okay.
What is the value of x?
7.
So you're adding 5 to both sides, hopefully, first. And then what did you get on the right? What's minus 29 plus 5?
Minus 24.
Okay, so when you divide by 3, what is 24 divided by 3?
Um, -7.
Negative
Wait,
8.
wait, sorry, negative.
It's negative 8.
Uh,
Yeah.
okay, I added 29 to both sides.
Okay, so once you get the variable on one side, you just move the constant. So let's backtrack here just a tiny bit. Um, okay, so here's a problem kind of like the one we just did. 5 plus 2x equals minus 15. Your focus was on the side with the variable.
Okay.
So I'm going to subtract 5 from both sides. You always look at the side with the variable and undo that first.
All right.
Keep going. See if you can solve this one on your own.
Oh, okay. Um, just -10.
No, no, when they're, well, it is negative, but it's negative 15 minus 5 is negative 20. Keep going.
Oh, sorry, I meant x equals -10.
Divide by 2. X equals negative 10. All right. Let's have you try another one here. Let's try this one. 2x minus 4 equals 12. Could you solve that for me?
X equals 8.
Yeah, now why do you think you're able to do this one so quickly? You think it was the negative signs that were the issue before?
Um,
Like this one had some negatives in it. I don't know, subtracting versus adding. You did that one really fast, and I mean, you're right. Um,
I'm not
I'm
really
just,
sure.
okay. Yeah, I'm just kind of curious. All right, let's go back to problems we were starting out with, which is when there's variables on both sides. All right, so when there's variables on both sides like this, you move from the smaller to the larger. So which is smaller, this one on the
3.
left or this one on the right?
Wait, is that like -5x and
It
negative
is.
3x or
Yes.
oh,
Yes,
so negative
exactly.
5x?
Yes. So how do you undo that? How do you move it to the other side?
Add.
Add 5x. And I like to do it in the same step, but I guess maybe that was unclear. So let's do it together here.
Okay.
So what, look at the side with the variable on the right. Which should you undo first, the 5 or the 2?
5.
The 5. So how do you undo it?
Subtract 5 on both sides.
Yeah,
Choose you with 6, so that'd be x equals 3.
very good. Okay. So this one's a little bit different. Just give this one a try. Slightly different than what we've been doing, but maybe it'll make sense. Kind of like a sub case of one of the ones we just did.
Okay. Yeah, I'm not really sure what to do actually.
Did you add 2a to both sides?
Yes.
So on the left, what's left is 0. So now you focus on the side with the variable. How do you undo this minus 15?
Add 15. Oh, so be a equals 3.
Yeah, exactly. All right, very good. All right, let me give you another one here to look at. 12 minus 4x equals minus 6 minus 10x.
Um, x equals -3.
All right, so did you add 10x to both sides?
Oh, oops, I added 4x.
Okay, now that still works, but this is the preferred way. So I'll show you the preferred way. We'll see what happens. So 12 plus 6x equals -6. Then you would subtract 12 from both sides. You'll see that you do get the same answer if you do them all correctly. X ends up equaling -3.
Hmm.
Okay, now let's look at some equations where there's multiple variables on one side, which means that you have to combine the variable first. So variables on same side, you have to combine like terms first. So what does 1x minus 2x plus 3x become?
4x. Wait,
Try again?
-4x.
Nope. 1
Wait,
minus 2. It's really just
One,
1 minus 2 plus 4. And you can, I mean,
wait,
you can
where's
add
four?
first. I'm sorry, 3.
Oh,
Giving you the answer. 1 plus 4, 1 plus 3 is 4. That's one way to do it.
um,
Still waiting for the answer.
oh, sorry, 4 minus 2 is 2. I was just
Yeah.
thinking,
Okay.
oh,
So
never mind.
this 2x minus 4 equals 8. So could you solve this for us, please?
Um, X equals 6.
Yes. Okay, so let's have you try one here on your own. Let's go 7x plus 6x plus 15 minus 10x equals 17. So first
Okay.
combine like terms, the x's. Anything that's on like one side of the equal sign, you can combine. What is 7x plus 6x minus 10x? What does that become?
Oh, 13x.
Try again. I mean, 7 and 6 makes 13. What about this minus 10x?
Oh, sorry, 3x.
Yeah, so you get 3x plus 15 equals 17. So it doesn't always work out as a perfect, number. Could be a fraction. That's okay.
Oh, okay, that's why I was kind of confused. All right. Um,
What's your final answer?
that would that would be 3/2.
So when you subtract 15, that gives you 2 on the right side. And when you divide by 3, it's 2 over 3. I
Oh,
heard I heard
oops.
the flip of that. It's a small thing, but it does make a difference. All right, let's try see if we can get one more in before we close out here today. At least one more. Let's go 10x minus 9 plus 2x minus 3 minus 8x equals minus 18, like that.
Okay. Okay. That's 4x.
It is 4x. 4x. And then this time you've got to combine the numbers as well. That could be another possibility. Minus 9 minus 3.
-12.
You have 12 equals negative 18. Good. All right, keep going.
Um, plus 12 to both
Okay.
sides makes -6. Wait, 4x equals -6.
Okay. So divide
Um,
by 4, reduce that fraction. What does that become?
-3/2.
Yes. All right. Let's see what else we got here. Here's one more here. 5x minus 7x minus 9 equals 11.
5x minus 7x. Okay. Negative 2x minus 9 equals 11. Um, Add 9 to both sides. Negative 2x equals 20. Negative x equals negative 10.
Right, coming in strong there at the end. Hopefully, kind of doing some equations help. Um, so we'll stop here for today.